Hello and welcome to this video on the normal distribution. So many things in the world are normally distributed. For example, the height of people in our class, or lots of other different things, they have a normal distribution. So say we have our random variable x. If it's normally distributed, we're saying that means that it has the distribution, and this is the normal distribution, and that it has mean mu, and it has variance sigma squared. And then, so this is kind of the real world. And then we convert this into a problem in the stats world. And in our stats world, we have our random variable is z. It's normally distributed with mean 0 and variance 1 squared. So this is 0, and here this is mu. And basically we use the fact that this is symmetrical, the probabilities, and this one's symmetrical too. And the probabilities all add to 1 underneath here, and the probabilities add to 1 underneath here. So we're going to whiz through skills 1 to 4 from your pack, and this is all in stats world. Okay, so we draw our z-axis and our curve, mean 0, and we're trying to find the probability that z is less than 1.78. 1.78 is about here. And so we're looking for this, so we put a question mark for the thing we're looking for, and then we just look this up in our tables, and we find that the probability that z is less than 1.78 equals 0.9625. Skill 2. Now we're trying to find some a such that the probability that z is less than a equals 0.9495. So first we have to say that this, because it's less than, so we've got our z-axis here, because it's less than a, we're talking about this direction, so it's area to left, and because this number is bigger than 0.5, we can say that the area to left is big. Okay, so we draw a curve. This is 0. Because the area to left is big, we know that a is somewhere here, and this area is 0.9495. So now again we just look in our tables, but we're using them in reverse, so we're trying to find this in the second column, and that tells us that a equals 1.64. Skill 3, now we're dealing with negatives. So we draw our z-axis, we're trying to find the probability that z is less than minus 0.38, so that's going to be somewhere around here. And we want to find the probability that z is bigger than, so that's this is what we're looking for. But our tables don't deal with negative numbers, you can see that we don't have them, so we're going to have to rewrite it like this, using the symmetry of it. So again we've got the z-axis, and now we're going to have positive 0.38, and it's this area that we're looking for. And these are the same, due to the symmetry. So now we look up in the table, we're trying to find the probability that z is less than 0.38, and that is 0.6480. Okay, we're trying to find the probability that z is less than some value, and it's this, which is small. So we've got area to left, because it's smaller than, is small, because this number is less than 0.5. So what we have is our z-axis, and this is 0. A must be somewhere here for this area to be small, 0.3372. So we're going to have to redraw this, because at the moment a is negative. So redraw this using the symmetry. So now this is 0.3372, and this is now minus a. Okay, so now we can say that the probability that z is less than minus a, so kind of this here, is equal to 1 minus the probability that z is bigger than minus a, which is this bit here, the bit we know. So that is 1 minus 0.3372, which is 0.6628. So now we're able to look this up in the table, this, and that will tell us what minus a is. And so we find out that, okay, I'm just going to write small over here, that minus a equals 0.42. Therefore, a equals minus 0.42, which makes sense because it's this side of 0. Standardizing. So we want to go from this world, the real world, to this world, the stats world, and we do it using this formula. Z equals x, take mu over sigma. So basically, if we've got a value on our x-axis and we want to find out what it's equivalent to on our z-axis, so how you get from here to here, we just use this formula, and I'm going to show you how that works. So now we have this random variable x, and it's normally distributed with mean 40 and variance 3 squared. So our x-axis looks like this, 40 is the mean, and the equivalent place on the z-axis would be 0. So they're kind of connected. And then what we're trying to find is the probability that x is bigger than 45. So 45 is going to be about here, and we want to find this equivalent bit on the z-axis. How we do that is using this formula, z equals x minus mu over sigma. So that's 45 take away 40 over 3, which is going to be 5 over 3. So this is 5 over 3. And now the thing we're looking for is the probability that x is bigger, so it's this bit here, and this is the area we want to find. So the probability that z is bigger than 5 over 3 is the same as 1 minus the probability that z is less than 5 over 3. And now we can look this up in our table, and we find that it's 0. And once we've done 1 minus our answer, we find that it's 0.0475. In this example, the thing that we don't know is the variance, so we're looking to find sigma squared. So we've got our x-axis and we've got our z-axis above. So our mean here is 24, and so that's equivalent to 0 on our z-axis. And we're talking about the probability that x is bigger than 30, so 30 is there, so we want to find the equivalent bit on our z-axis, and we use our formula, z equals x take mu over sigma, which is 30 take away 24 over sigma, which is 6 over sigma. So now we fill in our curve. We know that this area, so this we can label it 6 over sigma, and this area we know is 0.05. And now, because 0.05 is a nice value, and we've got the area to the right here, this is actually a p-value, so we can look it up in our table. And so this is the thing that's a p-value. And that tells us that the probability that z is bigger than 6 over sigma, when that's equal to 0.05, then this is going to be equal to 1.6449 in the p-value table. Okay, so if 6 over sigma is that means that sigma is 6 over 1.6449, which is 3.6476, and so let's round that 3 sig figs, it's 3.65 to 3SF. Okay, right, so now x is a random variable with normal distribution, mean 0, variance sigma squared. This is the thing that we're trying to find out. And we know that the probability that x is between minus 4 and 4 is 0.6. So let's draw what we know. We've got our x-axis and we've got our z-axis above and our curve. So this is 0, this is also 0, this is 4, this is minus 4. Okay, that is 0.6, that area. And using our code, z equals x minus mu over sigma, well, for this one, we get 4 take away 0 over sigma. So that one is going to be 4 over sigma. And then for the other one, and minus 4 take 0 over sigma. So this is minus 4 over sigma. Okay, so now we know that the probability that z is between 4 over sigma and minus 4 over sigma is 0.6. And we know that we can rewrite this as the probability that z is less than 4 over sigma, subtract the probability that z is less than minus 4 over sigma. And the reason we can rewrite it is that basically we're talking about this area subtract this area leaves us with the bit we want, which is this area. Okay, so when we have one that looks like this, we can always rewrite it like this, as the bigger area, subtract the bit we don't want. Okay, so we're going to need to use symmetry here, because this area here is the same as 1 minus this, because basically, because they're symmetrical, so it's the same as this area here. I'll do that in red. It's the same as this area, and so that area is the same as 1 subtract this area here, which is this one. So essentially we can rewrite this as the probability that z is less than 4 over sigma, take away 1 minus the probability that z is less than 4 over sigma, and that is equal to 0.6. Okay, so then we can rewrite this as, because, well, we've got probability that z is less than 4 over sigma minus 1 plus probability that z is less than 4 over sigma equals 0.6. So then we've got 2 times the probability that z is less than 4 over sigma equals 1.6. Just move this over here. So that means that the probability that z is less than 4 over sigma equals 0.8. Now I'm going to look this bit up in my tables, and the closest value I can get gives me that 4 over sigma equals 0.84. So sigma equals 4 over 0.84, which is 4.7619, which is 4.76 to 3 sig figs.